Hi. Right. This question we're going to prove some identities, or some of the identities. So this is one of the identities. So we're going to prove these identities. Secant theta plus cosecant theta over tangent theta plus cot theta will produce this sin theta plus cos theta. It's actually simplifying from this to get this, right? So you have to prove that this one you were getting this result here. So it means that we have to prove this identity that this is true. Alright. So I will using the left hand side because it seems like this is a very simplified. This is a very simplified form. So this is something that you may you used to simplify and getting that the right hand side. So you have tangent theta plus with cotangent theta, right? As you know that secant theta can be rewrite as 1 over cos theta, right? 1 over cos theta, and cosecant theta can be rewrite as 1 over sin theta, right? Cosecant theta 1 sin theta, secant theta 1 over cos theta. So divided by tangent theta. So tangent theta is defined by sin theta over cosine theta. And cotangent theta is cos theta divided by sin theta. So I rewrite all this into the very basic form, right? Like secant theta, you know, secant is 1 over cos, and tangent is sine over cos, all related to sine and cos, because I see finally they have only have the sine theta and cos theta. Alright. So now I'm going to modify this thing. Alright. Modify this thing. So there is a cos theta here, sin theta here. So either you combine this by making the denominator the same, equalize the denominator, or I would prefer that you multiply the cos theta and sin theta. Cos theta, sin theta. Because you see, this is a cos theta, this is sin theta, so I multiply with cos theta, sin theta, and this is also the same. I multiply with cos theta, sin theta. The purpose of this multiplication is it's a fraction, right? You can multiply up and down by the same thing. So now you see, you multiply, if you expand this inside here, so you have cos theta, this one and this one, it will cancel off, right? So sin theta and 1, you were getting sin theta, right? You have sin theta, and plus with sin theta and this, you have sin theta plus cos theta. Right, so let's see what is happened below here. So cos theta and cos theta, you have expanded inside here. So sin theta, cos theta, you look at this, sin theta, cos theta, multiply with cos theta, sin theta. So if you multiply, this will divide, right? Cos theta divided by cos theta, divide, right? Or you cancel off. So you have sin and sin theta, you have sin square theta, right? Sin square theta plus with this one, you see, cos over sin. So sin theta and sin theta, if you cancel off, you divide, you have cos, you have cos square theta. Then you must know the identity, the Pythagorean identity, which the sin square plus cos square is always give you 1, right? Always 1. So therefore, this will be giving you 1, right? Giving you 1. Definitely you are getting sin theta plus with cos theta. Proof. So you have already proved that this one, you will simplify become this. So let's look at another examples. Right, let's continue with this example. So I would like you to try the question first. Okay, you assume that you're watching this video as you're trying to prove these identities, and followed by checking with my the way of proving. All right. So this will be, we can see that from this side we were reaching this side, or either from this side we're reaching this side. Usually I will prefer that from a subtraction or addition or subtraction, then become a product form. Alright, so usually you see that how we have to imagine, we have to think what is the formula, okay, what is the identity that can helping us to from here to here. So first you see that there is a subtraction here, right, or addition. So you can rewrite this as a fraction to combine these two into a product form. So if you know that cot square theta minus cos square theta, from the left hand side I'm proving, So cot square theta, it will written as cos square theta over sin square theta, right? Because you know that cotangent theta is defined as cos theta divided by sin theta, right? So if you square this, this will be cos square over sin square. So minus with cos square theta, cos square is a basic form, okay, cos square theta. So now you have sin square theta, right? You have sin square theta. So what you're going to do now will be, this is divide by 1. So I want to combine these two fractions into one fraction. So I have to multiply this with sin square theta, right? That's the only way. So I multiply this with sin square theta. So that is divided by sin square theta, right? Divided by sin square theta. And this, so you have cos square theta minus with cos square sin square, right? Cos square theta sin square theta, right? So we are actually, you see that we have already combined this into a single one term, right? Two term become one term here. So then the cos square theta is a common factor, all right? I factor out the cos square theta. Then I have 1 here, right? Minus with sin square theta divided by sin square theta, right? Divided by sin square theta. So if you arrange 1 minus sin square theta, 1 minus sin square theta, there are identity, Pythagorean identity, which sin square plus cos square theta will be equals to 1, right? You know that. So then you have tangent square theta plus 1 equals to secant square theta, and followed by 1 plus cotangent square theta equals to cosecant square theta. So I think this one, 1 minus sin square theta, is very related to the first identity here. So where you can rewrite this thing as 1 minus sin square theta, okay, I can write 1 minus sin square theta is actually cos square theta, right? It's actually cos square theta. So I rewrite this whole thing as cos square theta, and this one also turned to be cos square theta over with sin square theta, alright? Over with sin square theta. As you see that, you know that cos square over sin square will be cotangent square theta, right? Then you can see that you are getting you have proof what you want. Cos square theta, alright, you were written as cos square theta, and these two, cos square divided by sin square, is written as cotangent square theta, right? With the help of Pythagorean identity, I have already proved that this one will be the left hand side and the right hand side actually the same. Means that this is also another identity, right? And this is a 3 basic identity, right? You can generate many identities for trigonometry. So this will be cos square theta, cotangent square theta. So I will give you another examples, more examples for you. Alright, let's look at this identity. Alright, let's proving this identity by using the the Pythagorean identity, the basic identity. So let's look at this one. Oh, very easy. From this one, you have actually reached this one, right? This is more simplified form compared to this, right? Okay, so we try to simplify this one such that you were getting that. Alright, so 1 plus cos theta. So you have left hand side here, you will have 1 plus cosine theta over with sine theta plus with sine theta over 1 plus cosine theta. So okay, the easiest way will be you look at these two, right? You look at these two, and this one you have sine theta, you will have sine theta, and the other one, the denominator, you have 1 plus cos theta, right? So it means that you need to equate the denominator. So you have to multiply this with up and down. You multiply with 1 plus cos theta, right? So here also you multiply with 1 plus cos theta, and this you will be multiplied with sine theta, and this one is also multiplied with sine theta, right? So then you were getting the same denominator, right? 1 plus cos theta sine theta, 1 plus cos theta sine theta. So I write here as 1 plus cosine theta sine theta, right? Sine theta, and this one you will be 1 plus cos theta to the power of 2 plus with sine square theta, right? We are trying, right? We don't know what will happen. Will it proving to be getting that? So we just decide, alright, what to do here is you see that the 1 plus cos theta here, you can actually 1 plus cos theta here, you can expand, right? We just expand. We see, is there any way we can simplify after expand? So you are getting 1 square plus with 2 cos theta plus with cos square theta, right? You expand the a plus b square, you have a square plus 2ab plus b square. So then I'm putting in back into the function here. So the expression here, I will getting 1 plus 2 cos theta plus with cos square theta plus with sine square theta, right? And then divided by 1 plus cos theta sine theta, right? So then you look at this, then there is something here, right? You can see that there is a cos square and sine square here, right? Cos square plus sine square. You should know that cos square plus sine square or sine square plus cos square is actually 1. So 1 plus 1, you have 2 plus 2 cos theta over with 1 plus cos theta sine theta, right? But finally, you can see that the numerator and the denominator have a common factor. Okay, if I factor out the 2, I factorize the 2, I will have 1 plus cos theta, right? 1 plus cos theta divided by 1 plus cos theta sine theta, right? And this one you divide, right? You'll be giving 1. So you have 1 over sine theta, right? 1 over sine theta. You should know that this will be actually a cosecant theta, right? This is I already proved from here. You're getting here by using the Pythagorean identities.